Okay, we're going to look at some parabolas in standard form. And standard form is this guy right here. You might recognize this because the A, the B, and the C value are the values we plug in to the quadratic formula. So this is called a standard form quadratic. Now, quadratic is just a fancy way to say the power, highest power, is 2. That's all it means when somebody says a quadratic. It means, oh, the highest power is 2. So we are going to look for the same type of information that we did before. Let me scroll down. They're going to ask us to state the vertex, the axis of symmetry, the y-intercept, and the number of x-intercepts. Now here's the key. Whoop. The number of x-intercepts means how many times does it cross the x. They're not asking specifically what those numbers happen to be yet, but that's going to fill up a lot of the remainder of this unit, is figuring out exactly what those numbers are. But before we get there, let's just go through the basics here and focus on our vocab. What is a vertex? Well, it's the highest or lowest point on the graph. What is the axis of symmetry? Well, that's the center line that cuts our graph down the middle. Y-intercept is self-explanatory. It's where it crosses the y. And then once again, we're just looking for how many x-intercepts are there. And remember, the number of x-intercepts could be 1 x-intercept, it could be 2 x-intercepts, or it could be none. All right, and then we're going to draw a picture. So here's my first example. And we're going to approach this a little bit different because this is not in vertex form. So the first thing we're going to do is figure out something called the axis of symmetry. Now the axis of symmetry has a teeny tiny little equation with it. To find the axis of symmetry, we use this guy. X equals negative b over 2a. And here we go. We already have a b value. Here's a c value. In the front here, they didn't write it in, but it would be a 1, and that would be my a value. So I'm just going to write them on the side here. A equals 1, B equals negative 4, C equals negative 3, and let's begin. So if I'm going to find the axis of symmetry, I would do X equals negative B. Now we already have a negative on that, so that's a double negative. So negative negative 4 over 2 times A, and the answer is going to be, well, positive 4, because 2 minuses make a plus, over 2, because 2 times 1 is 2, and we reduce that thing down, we get 2. So my axis of symmetry is x equal 2. Now, I stress that x equals 2 is our axis of symmetry because we don't just say 2, we say x equals 2, because anytime you write x equals a number, it means it's going to be a vertical line. So the axis of symmetry is x equals 2 is a vertical line that cuts our graph right down the center. Now, once we have an axis of symmetry, we can find the vertex easily. The vertex, just like it was in the last lesson, if I plug this number in for x, I can get out a number for y. And that pair of numbers will make up my vertex since we're in standard form. We're not in graphing or vertex form. So let's play with that. Let's do that. And you could use a calculator on this. You don't really need to because the numbers aren't that bad. So I'd say y equals 1, but not x squared. Instead, I'm going to put a 2 there. Minus 4, but not times x, I'm going to put a 2 there. Minus 3, because that's what my equation says. So just so you know, let me highlight this. I am taking this equation here, and everywhere I see the letter x, I'm putting a 2 instead of an x. So let's just crunch the numbers. Let's see what we have. So it'd be 2 squared, that's 4, minus 4 times 2, order of operations, that's 8, minus 3. So now all I have to do is combine all those numbers, add them up, and it looks like I'm going to get what? Negative 7 out of that. So the vertex for this will be when x is 2. Remember, when x is 2, I get out negative 7. So what have I found so far? I found the vertex. I found the axis symmetry. Now the nice thing about the y-intercept on this is the y-intercept for a parabola in standard form is always the same thing as the c value. So the c value is what would come out if I plugged in 0. I don't even have to do the work. If x squared, if x was 0, 0 squared is 0. If x is 0 minus 4 times 0, that's 0. I'm always going to get out the c value. So the y-intercept in this format is always the same as the c value. So now I have all 3 pieces of the puzzle, and I can actually sketch this graph. And once I do, I'm going to see where it hits the x-axis. So let's see what goes down. I'm going to sketch this graph. I am going to just make sure you guys get this. The axis of symmetry is at x equals 2. My vertex is at 2, negative 7. That's just a point on the graph. My y-intercept is at negative 3. And here we go. Let's draw this picture. And I know that if I go 2 to the right, I'll have to go down 1, 2, 3, 4, 5, 6, 7 units. There's my vertex. My y-intercept happens to be at negative 3. And since the center line, the axis of symmetry, cuts right down the center of my graph, since that goes right down the middle, I can use that to sketch this graph, because I know one thing about a parabola for sure is this side over here is supposed to be symmetric with this side over here. And that's not the best drawing in the world, but it isn't horrible. I can tell it's a parabola, and I can also answer the last question now. I can tell you that this graph obviously hits the x-axis twice. So the number of x-intercepts, there are 2 x-intercepts. Now the x-intercepts, like I said before, that's where we're going to end up doing a lot of work for the remainder of this unit. But for now, this is all I need you guys to get accomplished. Can you tell me these dudes? Tell me how many times it crosses and give me a decent sketch. And you can see that there's a little bit of work required, but not a ton. And let's look at another example. So here comes my second example. My second example, the numbers are a little bit different, but the process is still the same. Now, I'm going to make a little list over here this time, because I wanted to make sure I was very clear on all that stuff. So axis of symmetry is going to be one of the things I find. It's going to be x equals some number that I don't know yet. I'm going to find a vertex, and one thing I do know about that vertex, this number right here is going to be the same as this number right here when I find it. And then I'll have a y-coordinate. And then y-intercept, heck, I can do this right away, because I know that every time I do this, I have an a value, I have a b value, and whatever the c value is the same as the y-intercept. So let's get these guys going. They didn't write it in, so it's a 1. So I say a is 1. B is what in this one? It's a 6. And what is the C value? It's -2. So I already know my y-intercept. I'm just going to label it and say y-intercept is at -2. And away we go. Let's get our axis of symmetry. Remember, this is x. Whoops, sorry. Didn't mean to write that. X equals -b over 2a. Anytime I jot down a little formula or whatever, might not be a bad thing to have in your notes. Remember, open note. So here we go, -b, so that would be a -6 over 2 times a, so that's just 2 times 1 is 2. So I get -6 divided by 2, that's just -3. So I'm going to go over here to this question mark that I drew earlier, and I'm going to say, hey, I know exactly what you are. You are -3. So I know there's a vertical line. Anything that says x equal number is a vertical line that cuts right down the center of my parabola at -3. Let's take this value I just found. Let's take this guy and plug him in everywhere I see an x. And if I do that, what am I going to find? The y coordinate of my vertex. So here we go. I'm going to take the original equation, y equals 1 times x squared, but this time it's a -3 squared, plus 6 times -3 minus 2. So let's see what this thing turns out to be. Well, if I square -3, be careful here. If you're using a calculator, anytime you punch a negative number into a calculator without putting it in parentheses and you square it, it will actually lie to you and tell you the answer is -9. But you know better than that. -3 times itself, that's a negative times a negative. I should get a +9 out of that. Times 1, I'm still going to have 9. Well, then the next part of the puzzle, plus 6 times -3. Well, 6 times -3 is -18, so I'm just going to write it down as a negative, and then minus 2 more, and now I have to combine all these numbers. So 9, take away 18, take away 2 more, I get a grand total of -11. So what did I find? I found the y value is -11 when the x value is -3. And once again, I'm going to erase this little tiny arrow I had here, and I'm just going to remind you guys that this number is always the same as this number when it comes to the vertex. They're always identical. So I have all 3 ingredients I need to sketch this graph. So you can see this is speeding up. We're doing pretty quick work of this. I'm going to sketch my graph right over here. So let's see, come on. And I'm going to give myself a lot of room down below on this one, because I only have a limited working space, but I also know that when I plug in -3, I get out -11, right? So I needed to leave myself some space here to get all the way down to -11. Where is my y-intercept? Well, it's at -2. And once again, I'm going to connect these dots to draw a parabolic shape, so it's not a straight line between those 2 dots. I'm going to have to throw some curve at it, but that's what a quadratic does. Something that's got a squared like this, I'm going to end up with a parabolic shape. But notice that that a value, that thing's positive. So should my graph open upward or downward? And the answer is upward. So when I connect the dots, it's going up. So I'm going to just draw this side of my graph. But you know what? I want the other side to be a mirror image. So once again, I'm going to grab a different color pen and just sketch in. What is this little vertical line that I'm drawing right there? That guy's name is the axis of symmetry. So I'm going to just freehand sketch this other side so that it looks like the other one. And then it looks like I gobbled up my 11, so I'm going to do that. So there we go. We have a pretty decent looking sketch of that. It should be perfectly symmetric on both sides, but I'm a human being with limited art skills. So that's as good as my graph's going to look. But I was able to identify all the pieces of the puzzle, and here we go. How many x-intercepts? There are 2 x-intercepts. Now, do I know exactly where they cross the x-axis? No, I need to use a little more algebra for that, but that's not where we're at today. So let's get the rhythm down. We're going to use negative b over 2a. We're going to find a value. We're going to take that value, plug it back into the original. That's going to give us a corresponding y value for the vertex. C value is the same thing as the y-intercept, so that's a gimme. Then we're going to draw that picture. I have a couple more examples, and you might say, well, I don't need any more help. I think I got this. Well, what if they did this to me? This looks a little bit different. See, a quadratic, and we're going to play with this more this week. A quadratic is ax squared plus bx plus c. So I'm telling you right now, I don't see any number here, so I'm going to say plus 0. You see what I did there? See what I did? That gives me an easy way to identify, well, this time A is not 1, this time A is 2. My B value happens to be 8. My C value, well, there was nothing there, so I used 0 to hold the place. There's my A, my B, and my C. My A, my B, and my C. That's how it's going to work out. Now I'm going to erase this part so it's not in the way. Get it out of the way. Oh, too much stuff. Let's go back, and we're going to do the axis of symmetry. We're going to do the vertex, and we're going to do the y-intercept, which we already know is at 0. So this time, when I sketch my graph, I'm going to have this number here to play with. What does a number out in front do? It will either make your graph skinnier or wider. And in case you forgot from Algebra 1, whole numbers make your graph skinnier, fraction numbers would make it wider. And I know you're saying, fractions? We're not doing any fractions yet. Don't panic. So I'm going to say, don't forget this time when we do the axis of symmetry, x equals negative b over 2a. I'm going to plug in negative 8 over 2 times 2, because my a value is 2. That gives me negative 8 divided by 4. That's just negative 2, and that guy's called my axis of symmetry. But remember, he's an x value. He's a vertical line. So I say x equal negative 2. That also means when I draw my vertex, I'll have negative 2, comma, something I don't know yet. But here we go. Let's go find that thing. I'm going to plug it into the original. I'm going to say y equals 2 times x squared plus 8 times x. And if it makes you feel happy, you can put the 0 there, but it won't matter because if you add nothing, you got nothing. But here's where you got to be careful. Don't let your calculator lie to you. This time, if you were going to use a calculator, I'm not saying you can't, but you'd have to punch it in using the parentheses exactly how it's written. This is where people get sloppy because they just, oh, the calculator's not going to lie to me. It'll tell me what I want. But you have to punch it in exactly how it's written. And on your calculator, you'll notice there are usually parenthesis keys there. But let's just do it by hand. I'm going to say order of operations. I'm supposed to do exponents first. So I would do negative 2 squared. That's 4. Then I'm going to do 2 times that 4 plus 8 times that negative 2. So let's just cut to the chase. That is positive 8. This is negative 16 plus 0 if you want. But what's the grand total? It's negative 8. So I go, oh, when I plugged in -2, I got out -8. And I have enough ingredients to draw this picture. I'm going to do it over here. And is this parabola going to open upward or is it going to open downward? This guy's going to open upward because 2 is positive. If the A value is positive, if A is positive, it's going to open up. So here we go. I got -2. I go down 8. I have a vertex. I have a y-intercept. When I connect the dots, it looks like this graph is going to be pretty skinny because that 2 in the front. Now I still have an axis of symmetry that helps me kind of eyeball my drawing. And I hand sketch the other side. And yeah, that parabola is a little bit skinnier than the last one that we drew. Got all my ingredients on the side here, right? Axis symmetry, vertex, y-intercept. There's my picture. There's all the work I had to show. So guys, I expect to see some work from you. Not a ton, but remember, I cannot prevent you from using, notes to help you. So you might as well have really good detailed notes. I have 2 more examples because I want to show you all the things that could possibly happen to you, and one of the things that can happen to you we have not seen yet. Oh, by the way, there are 2 x-intercepts. Hey, and I might as well mention, if your y-intercept is at 0, you obviously can see that it's going to cross at x equals 0. Remember, if you cross at the origin, you automatically know y is 0 and x is 0. But there are 2 x-intercepts there. Let's go to the 4th one, because I got 2 more. And this one's a little bit different because, I got a -a value, but it seems to be missing something. Remember, y equals ax squared plus bx plus c. So when I go to grab my a, b, and c, so a this time is -3. Is my parabola going to open up or down now? It's going to open down because a is negative. But I don't see an x to the first thing, and that's because I don't have one. This time the b value is 0, and the c value is -1. So if the b value is 0, this creates kind of a weird situation, and let me explain this to you. I wanted to make sure we saw one just like this, because you're going to see one on the assignment. Here we go. Axis of symmetry is at x equal, well, if I did -b over 2a, if I do the axis of symmetry calculation, and b is negative, nothing is nothing. Over 2 times a, well, that's just nothing divided by -6, or negative nothing divided by -6. I get nothing. My axis of symmetry is at 0. Now think about it a little bit ahead of time. If x is 0, my vertical line that I draw goes right down the y-axis. It's right in the middle of my graph. So wait a minute. If I take the 0 that I just found, remember that's going to be part of my vertex. If I take that 0 and plug it back in, so y equals -3, I've got nothing squared minus 1. Well, this is nothing squared is nothing, times -3 is still nothing, minus 1. The only thing that's going to come out is -1. So I go, oh, okay, -1. And my y-intercept, wait a minute, my y-intercept is at -1. So this is why I wanted to make sure we saw one of these. Because when I go to sketch this graph, I know this graph is going to go downward. I know that. But let's put the pieces together. My vertex is at 0, -1. So that means I'm going to go, well, I'm not going to go sideways at all, but I am going to go down 1. So I have a dot. And then I look at that and I say, wait a minute, that dot is the same as my y-intercept. How can I sketch a graph if I only have one dot? I can't. But what I can do is I can plot any other point and connect the dots. But let's stop for a second here. And remember, I do have an axis of symmetry. It goes right down the middle of the thing because the axis of symmetry is 0. So I go, well, where's this graph going? The one clue I do know is it's going downward. I know this graph is going to go down. But how steep is this graph going to drop? So let's go get a pen and do a little work. See, when you only have one dot, when you only have one dot, you cannot sketch a graph. It's not much of a parabola if it's just a dot. So what do? You pick any other number you want for x. Any number you want. Pick the easiest number you can think of. 0. No, we already plugged in 0. Remember, that was the axis of symmetry. 1. Hey, I'm going to do that. So here, when you only have one dot, pick x equal 1 and plug it in and see what you get. So I'm going to do y equals -3 times 1 squared minus 1. Well, order of operations. If I square 1, I'm going to get 1. 1 times -3. Well, that's just -3. Minus 1 more, that equals -4. What did I achieve there? Well, if I plugged in 1 and I got out -4, that's just a point that I can plot. That's one extra piece of information. I plugged in 1, I got out -4. So you can see I can still sketch a graph then. Whoops, make that dot bigger so it looks like I hit it. And the other side's going to be a mirror image, so it's going to go like that. And this is a graph that opens downward. It is very skinny because of the 3. And this time I have no x-intercepts. It doesn't cross the x. Okay, no x-intercepts. So my sketch is based on just the 2 points. But remember, hang on, let me get this color. When you only have one dot, this is the key. Pick x equals 1 to finish your graph off. That way you will get another point. In this case, it was when I plugged in 1, I got out -4. I plotted the point, I could connect the dots. You're going to run into one like that. Be on the lookout when there's no b value, when b is 0. Okay, guys, we have one more example because I wanted to make sure that we saw another one that had all the goods in it, but we haven't done one that has all the stuff with this guy out front. When they just put a negative out front, here's the thing. What that really stands for is there is a -1 out front. And here's the part I don't want you to mess up. When you plug your numbers in for this, the x squared part, the squared does not hit that negative. I will point that out, but that's the part that usually messes everybody up. But not right yet. Let's get the goods. A equals -1. B equals -4, C equals -4. That's all good to go. Let's grab a black pen here and let's do an axis of symmetry. I'm going to do x equals some number I don't know, but what is that number? X equals -b over 2a. So be careful because I have a -4 over 2 times a, which is negative, so don't make a sign error. That's a +4 divided by a -2, so I'm going to get out -2 for an answer. There's my axis of symmetry. And what am I going to do? I'm going to say, hey, I'm going to plug that -2 back in to find out my y value, but here's where you got to be careful. -1, parentheses. -2 squared, -4, parentheses, -2, and then -4. And if you have a calculator with parentheses on it, and you type it in exactly how it's written there, it should not mess you up. But here's the thing, don't do -1 times -2 first, you're going to lose. That's not the order of operations. Remember, order of operations, we do the exponent part first. So I would do -2 times itself, that's 4. Then I'm going to multiply that by -1. And if I don't, I'm going to end up with a sign error. Here, I have -4 times -2, that's 8. And then I got another -4. So let's see what we got here. That's -4 plus 8 minus 4 again. Wait, I get out 0. Sometimes people, when they get out 0, they think they did something wrong. But no, that's what happened this time. So my vertex is, when I plugged in -2, I get out 0. And we can find our y-intercept real fast. It's the same as the c value, so y-intercept -4. I have all the ingredients I need to draw this graph, and let's do it. I'm going to do it right here. And I gave myself a little room down below because I noticed this graph is going to go downward. And at x equal -2, y equals 0. So boom, that's my vertex. And I'm going to drop from there. So it goes down 1, 2, 3, 4 units. There's my y-intercept. I'm going to connect these dots and draw a parabolic graph, but that's only half of it. Remember, we're going to go grab, whoops, come on. Come on, blue pen. Here's my axis of symmetry. And let's go get it. There it is. The other half is going to be a mirror image so I can get a decent looking parabolic graph. And guess why number 5 is the one unique question we haven't seen yet? There is only one x-intercept on this one. There's only one x-intercept. So that can happen to us because parabolas either cross the x at 1, 2, or no places. All right, guys, so this assignment here, just follow my pattern of work here. Show me something. Let me tell you, when we do take a unit test, if you get everything right, that's fabulous. But if you get something wrong and I have no work to see, I can't give you any points. I am always looking to help you out. So see what I got here? That's a lot of work. And if I can find a mistake and that's why your problem didn't work out or something, it's totally worth your time to show me the work. So this assignment, I'm going to scroll up. Here we go, because this is the last example. And here's all our other goop that we just did. Here it is. It says, state the vertex, axis of symmetry, y-intercept, and number of x-intercepts. Sketch the graph. So please pause it right now. Take a picture of it. That's your assignment. You have 10 pictures to draw me. And I don't want you to, do it without checking your work. So here's the answer key. But I couldn't fit it all on one page, so I'm going to show you part of it. So here we go. Here's the answer key. 1, 2, 3, 4, 5, 6, 7, 8, 9. Pause it, take a picture. And then here's the bottom 2 because I couldn't fit them all on there. Pause it, take a picture. All right, you'll also notice I did not draw any graphs. That's up to you. You're going to be the one drawing the graphs. Okay, so guys, I got to tell you, our next lesson has to do with some weird, funky number action. Before we can start finding all the x-intercepts for things, we have to learn something about what it means when there are no x-intercepts. So the next lesson has no drawing of parabolas in it. There's no graphing in it. But it's an important lesson before we go any further. But here you go. Once again, there's the 10 questions. All right. And as always, if you have any questions, please ask them. All right. Catch you later.